Hey, my little triglets, how's it going? Welcome back to Trig Online. Today we're going to talk about section 3.4. Section 3.4, we're going to talk about circular functions. And of course, by that name, we're going to be working on the circle quite a bit. Few things in review. Remember on a 45, 45, 90, we have a 1 to 1 to root 2 ratio. You could also call it x to x root 2, if that's how you learned it. If we have a 30, 60, 90 triangle, here's 30. This side is x, this side is 2x, and the long side here is x root 3. So if I have 2, this becomes 4, and this becomes 2 root 3. So a couple quick ideas there that you're going to need to know for this section. The other couple little things I need you to remember is SOHCAHTOA. SOHCAHTOA is an ancient formula, and it's what you do when you close your foot in the door. You SOHCAHTOA. You SOHCAHTOA. You feel better. But if that's not what you're thinking of SOHCAHTOA, hopefully it means the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. So those are different things that you just have to know to be able to understand what we're going to talk about next. Now, in a circle, if I were to draw a triangle, an angle up right here, theta, and finish the triangle within that, we have an x value and a y value, and this is considered the radius of that circle. Now, if this angle down here is the one I'm talking about, right here, then the sine of that angle theta is opposite over hypotenuse. Opposite, whoops, opposite over hypotenuse, which in our case would be y over r. The cosine of that angle is adjacent over hypotenuse, so that would be x over r. Adjacent is the side connected to the angle, so x would be adjacent. Y is the side opposite, so y would be the opposite side. And then tangent is opposite over adjacent, which would be y over x. Now these are the two we're going to be most concerned with right now in this lesson. If I were to tell you that, let's go to a new page here. Let's say I want you to find the sine and cosine of an angle that has its terminal side that goes through the point 2, 5. So watch what I'm going to do here. I'm going to draw that same circle. I'm going to estimate the point 2, 5. I'm going to go about 2 to the right and 5 up, and I'm going to make it land on there. Then I'm going to finish the triangle. So this side's 2, this side's 5, and then this side is r, which we're going to have to figure out. Because if we're going to find the sine of that angle, we need y over r. And if we're going to find the cosine of that angle, we're going to need x over r. Now, I bet you all know how to find r, given that that's a right triangle. And if you don't remember, I will just give you the answer here. X squared plus y squared equals r squared. It's good old Pythagorean. So x squared is 2, y squared is 5, and r squared. So 25 plus 4 is 29. So r is the square root of 29. And because it's a distance, it's just always considered positive. So over here, y over root 29. And then don't forget, you got to get rid of that denominator. Rationalize. So my final answer would be 5 root 29 over 29. That would be the sine of that angle. And if you wanted to actually figure out what the angle was, you'd have to do inverse sine of this answer. So this is a way to find angle measurements just by knowing the lengths of the sides. That's what SOHCAHTOA does for you. For x, it's going to be 2 over square root of 29, which getting the radical out of the bottom is 2 root 29 over 29. So there are the two answers. It's really not that hard. You just got to be careful. Now, this next one I'm going to give you, it's the same problem. The point that we're going to go through is negative 3, 4. So I'm going to draw the circle. I'm going to estimate going left 3 and up 4, approximately there. So 3 negative and 4 up. And then I'm going to finish the triangle. Anybody know what the radius is here? 3, 4, and 5. Should recognize that. That shows up on the ACT quite a bit. So 3, 4, 5 is the triangle. Now the angle that we're actually doing is this one. That's the theta that we're finding answers to. However, when we do the problem, we're going to be looking at this angle in here. They call that the reference angle. The reference angle is the one inside the triangle. But you always start on the x-axis and start from there to figure out which angle you're actually getting the answers for. So let's do this. The sine of our angle is still y over r. Y is 4, r is 5, so 4/5. Cosine of the angle is negative 3/5, x over r. So those are our two answers. Very simple. Just be watching out for your positive and negative signs. All right, let's review in our coordinate grid. Notice I did call it a coordinate grid. Coordinate grid starts with a C. So if you're going to label the quadrants, you do it like a C. So this is 1, this is 2, this is 3, this is 4. So I want to label all the sines and cosines here. Now cosine is your x, so I'm going to say cosine and then sine. So if I had an ordered pair, cosine would be plus, sine would be plus. X would be plus, y would be plus. In the second quadrant, for cosine and sine, I'm going left and then up. So cosine's negative, sine is positive. Third quadrant, cosine and sine, I'm going left and down to get to that quadrant. So they're both negative. And then for the fourth quadrant, cosine and sine, cosine, I'm going to the right for x, which is positive, and going down for sine, going down for sine, which is negative. Okay, so just, if you're going right, it's positive. If you're going left, negative. Up, positive, down, negative. So if I want to know what sign, is it plus, minus, or 0? Those are the directions. Cosine of 45. Draw a circle. 45 degrees is right here. First quadrant, everything is positive, so we'll say plus. How about cosine of negative 45 degrees? Well, negative 45 is down here. You're going downward. We're in the fourth quadrant. Cosine is your x value. So I'm going to the right and down to get there. So cosine is x, which is the right. So it would be plus. What is the sine of pi? Well, pi is right here. Sine is your y value. Y is up or down. Are you going either up or down to get to there? If you start at the origin, you're not moving up or down. You're just going left. So the sine of pi is 0. You're not going up or down, so there is no sign to it, no plus or minus sign. Um, all right, so I have one more problem to show you, and it just kind of puts everything together into one idea. So I have theta has its terminal side is in the quadrant 3, and I want you to find the exact. Now, exact is going to get underlined with all different colors to emphasize. Whoa, gotta go backwards to emphasize that it's very important that you understand what that means. Exact means no decimals, no rounding, leave it in radical form. So I want you to find the exact value for cosine of theta cosine of theta. Okay, what's going on here? Try this one more time. Cosine of theta if sine of theta is 1/2. Okay, first thing you're going to do is you're going to draw a triangle in the third quadrant. Over, down, finished triangle. Any size will do. We don't know what size. It doesn't tell us anything else. Now it tells us sine actually has to be -1/2. Sine, remember, is y over r. So let's label our y, this up and down, is -1, and r is 2. If you can just figure out what x, I can figure out what cosine is, because cosine of theta is x over r. So Pythagorean theorem, x squared plus -1 squared equals 2 squared. X squared plus 1 equals 4. X squared equals 3. So x is the square root of 3. Now what direction are we going for x? We're going to the right. So that means it's going to be a positive root 3. That's the part you got to be careful of. If you're, oh dear, I just realized my mistake. You're probably going, that's the fourth quadrant, Mrs. Kendrow. So let me redraw it over here real quick. -1, 2, x. So x is actually going to the left. So I need to erase this, and I need to put a negative on there. So cosine is -√3 over 2. So there's your final answer. So, okay, forgetting about my little mistake, but although it helped because it pointed out going to the left in the quadrant means it's going to be a negative. And because this, technically, x would be plus or minus √3. So you have to determine, is it the plus or is it the minus? And that depends on which quadrant you're in. So that is it for today. Don't forget, if you give a little bit of love to Trig, it will give it back exponentially. Ta-ta.